and dividing rational expressions. Let's see here. 2x over x squared minus 9 multiplied by x plus 3 over 4. Let's take a look at this equation. What we're going to do is we're going to factor. We're going to be factoring. So let's try to find some low-hanging fruit here. X squared minus 9. I know that that's going to factor to x plus 3, x minus 3. If you're wondering how I know that, it's because it's a difference of squares. 9 is a square, x squared is a square. Okay, we're multiplying. Okay, this is a simple one. First things first, we can go ahead and cancel x plus 3 multiplied by, we can cancel these cross terms out, so we're left just with 2x over x minus 3. And we can go ahead and write 2x over 4 x minus 3. All right. Yeah, that'll be your final answer there. 2x over 4 multiplied by x minus 3. Let's see if we can take that any further. Lower the weight on that a little bit. Two x over 4x minus 12. Yeah, that looks good. Let's try another one. Take a minute and try this one if you would like. So I'm going to work over to the side here. X squared minus 16. What do you notice about 16 and x squared? They're both perfect squares. And the format of a perfect square is x plus something, x minus something. And the something is always the second number's perfect square. So 4 times 4 is 16. So in this case, it's going to be 14. Sorry, 4. So the top term simplifies to x plus 4, x minus 4. Now we're going to factor out this term, x squared plus 3x plus 2. So a little shortcut. We know we end in a positive term, so it must be x plus something, x plus something. We find that something, and this is just a quick rehash. I recommend if you're not familiar with this, to go ahead and watch a video on factoring. But we find that something by what number plus a number equals this term, 3, and that same two numbers product equals 2. And I always express it as this. R plus S equals B, and R multiplied by S equals C, when the middle term is B and the third term is C. That's how I remember that one. So let's think about this. What is 3 times 1? Well, when that's not close. 2 times 1. Well, let's see. 2 times 1 obviously equals 2, and 2 plus 1. Let me reorganize that actually. I don't want to confuse you. So R plus S, 2 plus 1, does in fact equal 3, and 2 times 1 does in fact equal 2. So yeah, in this term we can say is x plus 2 and x plus 1. Alright, so now we rewrite this expression as x plus 4 multiplied by x minus 4 over x plus 2 x plus 1. And that is multiplied by x plus 1 over x minus 4. So when cross terms are identical here, when I say cross, I mean this way. The denominator here is identical to a numerator over here. They cancel each other out. For example, x minus 4 cancels out x minus 4 down here. X plus 1 cancels out x plus 1 here. So that only leaves us with two terms. The final answer will be x plus 4. Yeah, let me write this up here. Equals x plus 4 over x plus 2. And I'm simply taking these terms over here, these terms over here. So this big, long equation here simplifies to this, x plus 4, x plus 2. And we accomplish that through factoring. And let's do one more. All right, as always, take a moment, attempt this problem on your own, and then follow along as I solve it. Okay. We're going to approach this one much the same way, but we have a twist. This is a division term. And when we divide by a fraction, to solve that problem, we simply multiply by the reciprocal. Okay? And I'll take you to that point when I get there. That actually reminded me of something. Let me go back up. When you're solving these kinds of equations, you must find the domain. The domain is all numbers that x can equal. And in these rational expressions, if the denominator ever equals 0, that expression would be undefined. So let's find the domain of x, which is going to be all real numbers. So I'm going to write it as x must not equal, that's what this symbol means, the following numbers. So let's see. Here in this denominator, we have x plus 3 and x minus 3. So let's think about that. If x equals 3, it would equal 6 here. But if it equaled negative 3, it would equal 0. So x must not equal negative 3. Okay, and on the other side, x must not equal 3. And in addition, I see here 4x minus 12. That's okay if it was 0. And x must not equal, no, it could equal 0. Because if it equaled 0, yes, it could equal 0. All right, let's find it for the next one. And you should do this along the way. So let's see here. X must not equal, let's see here. We have x plus 2, so x cannot equal negative 2. X cannot equal negative 1. And x cannot equal 4. These are the numbers x cannot equal. Back to the third equation. Let's approach this step by step. X squared minus 9x plus 18. So we're going to use our r times s and our r plus s must equal negative 9 and 18. So we're going to use that again. So another shortcut, so we go ahead and write x. We have a negative number here and a positive number here. So we know when we multiply a negative number, one negative number would create a negative product. Two negative numbers would create a positive product. And here we have a negative number. So we're going to have two negative terms, most likely. So let's think about this. What plus what equals negative 9? A number that jumps to my head is 3 and 6. 3 plus 6 equals 9. Negative 3 plus negative 6 equals negative 9. 3 times 6 also equals 18. So this will be negative 3 and negative 6. Okay. We're going to keep track of our domain up here. Remember, these numbers are in the numerator, so we don't need to include those in the numbers or exclude them from the values of x, possible values of x. Now we're going to solve for this bottom one here. Let's see, x squared minus 25. We have another difference of squares. We can factor this as, what is it? It's x plus, and it's x minus. Do you remember what a difference of squares, how to solve that? It's the square of the second number, x plus 5, x minus 5. So that's our denominator. Now we have a term in the denominator, so we need to go ahead and exclude both of these, both of the values that would equal 0. Because if this term equaled 0, we would multiply 0 by both terms here, and would all equal 0. So negative 5 cannot be included, and 5 cannot be included. I have a feeling we're going to have some more. Stay tuned. Okay, so we have both sides of this. So let's go ahead and write here x minus 3. This is my numerator. X minus 6. And this is my denominator. X plus 5. X minus 5. Okay. Doing great so far. The second term. Okay. So now let's deal with this division here. As I said earlier, division with fractions is the same as multiplying the reciprocal. When I say the reciprocal, x minus 5 and x minus 3 are going to switch places. So we're going to rewrite this as x minus 5 over x minus 3. All right? Your alarm bell should be ringing now because we have a new x value in the denominator which can make us divide by 0, and that value is 3. 3. All right, take a look at this and understand that we have some terms that can cancel out. X minus 3 cancels out with x minus 3. X minus 5 cancels out with x minus 5. And we're left with x minus 6 over x plus 5. So this whole expression equals this. I have one extra question you can do if you would like. I'm not going to solve this one for you. Let's move on down to it. This one's a little tricky. You'll have to use all the tools you've learned so far to solve this one. Thanks for joining.